In this video, I'm going to be showing you 4 ways that resistors can be used in a circuit. Number 1, resistors can be used as a current limiter. Number 2, resistors can be used as a voltage divider. Number 3, resistors can be used as a current divider. Number 4, resistors can be used in voltage amplification. Now we're going to start with number 1, a current limiter. Here I've got an LED in series with a resistance and a 10-volt source. I want 20 milliamps or 0.020 amps flowing through the LED. I know that my LED voltage is 3 volts, which means that the voltage drop across my resistance will be 7 volts, because 7 volts and 3 volts equals 10 volts. So how do I determine what value of resistance goes here? What I do is I divide 7 volts by the current that I want flowing through the circuit, which in this case is 0.020 amps. Seven volts divided by 0.20 amps, that equals 350 ohms. So if I wanted a current of 0.020 amps flowing through my circuit and flowing through my LED, I'm going to need a 350 ohm resistance for a 10-volt source and a 3-volt LED. If I wanted, let's say, 25 milliamps or 0.025 amps, what would the resistance value be here? Well, I will still have my 7 volts across the resistor, and I will still have my 3 volts across the LED. So I'll go 7 volts divided by 0.025 amps. Now I will need a 280 ohm resistance. Okay, so this is an example of how you can use resistors as a current limiter. But number 2, you can also use resistors as a voltage divider. Now, here I've got a 10-volt source. I've got 2 resistors in series, and at this point right here, I will be taking my output voltage. If the resistances are equal in value, let's say I have a 500 ohm resistor here, and I've got another 500 ohm resistor here. Now I will have 5 volts here and 5 volts here. 5 volts and 5 volts equal 10 volts, and the reason why the voltages are the same is because the resistors are equal. But what if I wanted, for example, what if I wanted 4 volts here and 6 volts here? Now, I want to keep my 500 ohm resistors right here. But now, what resistor value goes right here? Well, what I'll do is I will determine the current flowing through the circuit. And I'll go 6 volts divided by 500 ohms. 6 divided by 500, 6 volts divided by 500 ohms, that equals 0.012 amps. So now I know I have 0.012 amps flowing through the circuit, which means that 0.012 amps will also be flowing through this resistor. Now, how do I determine what the resistor value is here? Well, I go 4 volts divided by 0.012 amps. 4 divided by 0.012 amps, that equals 333 ohms. So on a 10 volt source, this is a 500 ohm resistor here, 6 volts across it, I have 0.012 amps flowing through the circuit and 4 volts here with a 333 ohm resistance. So this is an example of how you can use resistors as voltage dividers. Now, number 3, you can also use resistors as a current divider. Here you have a parallel circuit. Now here you have the volt source, right? Now in a parallel circuit, the resistors is going to be sharing the same voltage as the volt source, Vs and Vs. However, the current will be split. This is the exact opposite of this circuit right here, where over here the voltage is split and the current is the same. Over here, the voltages are the same and the current is split. So now you've got IT or I total, which is the total current. Okay, the total current is flowing from the volt source. When it gets to this node right here, some of the current splits off and flows through this resistor. We call that current I1 flowing through resistor R1. The rest of the current flows through resistor R2, and we call that current I2 and the resistor R2. They go around the circuit, and at this node right here, both currents flow through this node back to I total again, and the process repeats itself. Number 4, resistors can also be used in voltage amplification. Now, this device right here is called an operational amplifier or op-amp. These signs right here, minus and a plus, it's not really talking about positive and negative. It's talking about the input. This one is the inverting input. This one is the non-inverting input. Now, here I have a 10K ohm resistor at the inverting input and the output. Here I have a 5K ohm resistor at the input and the inverting input. Now, I have an input signal here of a 1 volt peak-to-peak sinusoidal wave. Now, what would the output voltage be? Well, the way you find the output voltage is to take the RF or the feedback resistor value and divide that by the R value, 5K ohms. So I go 10K ohms divided by 5K ohms. Now, the K ohms go, and that equals 2. Now, that means I now have a voltage gain of 2. So what do I do with this factor of 2? Well, I multiply the factor of 2 by this input voltage of 1 volt right here. That means an input voltage of 1 volt with a feedback resistor of 10K ohm and a resistor at the non-inverting input, at the inverting input of 5K ohms, That would mean that I have a factor of 2, and I take that 2 right here and multiply it by the input voltage of 1 volt, which means that I've got an output voltage of 2 volts. If this were 2 volts, with the same resistor values, with the same resistor ratios, I multiply the 2 volts by 2, and I would have an output voltage of 4 volts. If this were a 3 volt input, and I still have the same ratio between the two resistors, it will be 3 times 2, and the output voltage will be 6 volts. And this brings me to the end of the video, and I'll see you in the next one.